Proportion, similarity, and congruence, Unit 3, is all about transformational geometry. You will learn how to identify and create translations, rotations, and reflections, and apply the concepts of rotational and reflectional symmetry. But let's define transformation, first of all. It's the moving of all points in a geometric figure, according to a certain rule by a rule. And the same rule is applied to all the points in that geometric figure. Here are some very popular transformations. Rotation. You move this point a certain number of degrees here, this point a certain number of degrees there, this point the same number of degrees there. These transformations that we're looking at reserve the size and the shape, or preserve the size and the shape of the figure, of the original figure. Let's look at some more definitions. If the transformation preserves the size and shape of the object that we are transforming, we say that the image is congruent to the pre-image, meaning that the shape after you slide it or turn it will be the same exact shape as the shape before you slid it or moved it or turned it or reflected it. So if the image is congruent to the pre-image, we say that that transformation is a rigid transformation. In other words, it preserves the size and shape. Another name for a rigid transformation is an isometry, which literally means same size, same measure. If the image is not congruent to the pre-image, then we say the transformation is a non-rigid transformation. In other words, the size or shape or both will change. In today's lesson, we will discuss 3 types of rigid transformations, or isometries. The first is translation. And a translation is when you slide a figure a given direction and all the points will go the same distance along parallel paths. Now, the most common mistake that people make when they are translating an object is that they forget to take a corresponding part and slide that corresponding part the same distance. So for instance, you can count the number of little squares that this slid, this point A to get to this point A prime. Point B will have to go that same exact number of spaces. And in fact, I'm going to take a moment and count those spaces. Why don't you do the same? So I counted 19 spaces. So if I'm going to move this point B and make it a translation of the shape, I have to also slide it 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. It goes here to B prime. A mistake that a lot of people make is that they try to say that they're just going to slide it from here to this point, right there. And those points are not corresponding. You have to slide it all the way to the corresponding spot. And it's going to be the same exact number of spaces that you slide it when you make a translation. So if one point is translated 5 centimeters, every single point will be translated 5 centimeters.